A calibration switch is really useful in order to allow users to be able to switch between different maps on their ECU on the fly or via steering wheel controls. Some of our plug and play kits utilise the CAN bus based buttons on the steering wheel in order to send CAN data in, and other ones use a external calibration switch that uses a diode chain like shown in the picture on the screen now. Now when you've got the normal calibration switch like shown on the screen a minute ago, these need to be actually assigned just purely to the calibration switch. And then after doing so, and you've assigned it to the correct input, under sensors and then calibration switch, what you can do is go to multi-position switch, because that's what it is, and depending on the input that you've used, if you've used a input that's like a unipolar or a resistive input which has the pull-up, then you need to make sure that the pull-up is obviously turned on, because that will pull the voltage up through the diode chain to allow the voltage change to the voltage step to change as you turn the switch. Then what you can do is you can change the threshold voltages to the output voltage from the switch to then assign each threshold to a calibration position. So as you can see here at the moment, the maximum position is set as 3, so I've only allowed 3 positions, but under thresholds the maximum amount of positions available on the calibration switch is 12. So you actually have here the slots to be able to assign that the threshold voltages for each of those. So what you would do is you would just double click on cal switch voltage or open a gauge for it, and then as you turn the switch you can see the voltage for each mode and then adjust the thresholds. As it's a blue item, you will need to program the ECU for these changes to take effect, and after doing so, turning the switch, you will be able to see the calibration switch change. Now on this particular car, this has actually got an up and down switch. What this means is that there is 2 inputs that are assigned, one for the up and one for the down control, and we've also got this override switch which allows us to actually think of it as an overboost button, where you can press an override switch and it will override all the calibrations that are existing set, and you can jump to a certain map, which I will come to in a minute. So the up and down switch is basically assigned to the inputs that you wish under pin assignments, and you can see here that I've got cal up on slave AN21 and cal up and down as well. Now the reason for this is because the voltage will actually go up to 5 volts when pressing the up, and then down it will go below. So if we actually click on here and actually look at the cal switch voltage, which you can see here, when I press the up button you can see that jumps to 3.7, and when I press the down it goes to 4.3. Now what we can do here is, instead of using the polarity setup, so we can say if it's active high or active low, which would mean basically if the value is above 3.75 volts it would be active high, and if it's below 1.25 it would be active low. Because we're in these different ranges, we actually use the in-range voltage mode. So we set that to yes, and then under the input for the up you would say up. Okay, so I'm pressing the up button now and it's reading 3.773, so I would set the up input low voltage threshold to be between those 2 points, so 3.6, 3.9, and then that way it would jump to that. And then the same for down. When I press it down it goes to 4.3, so the low is 4.2 and 4.5, and then when the voltage is stable in between those 2 thresholds it will then classify that as an up or down position, and you can see that by clicking on the up and down here. So when I press up it would go to on and down to there, and you can actually see the calibration switch here highlighted changing when I press it. Now the maximum amount I've got is 3, but the override will allow it to jump higher than that. So let's go over this override. So the override you can obviously do as a push to make switch. So when you press the button for the override, it will basically send a voltage into the ECU and then trigger the override switch, which you can actually show on here. Now I've actually got that on the same input as the up and down, and I've used this in voltage control again. So when I press the button on the steering wheel, it jumps to 3.14, which is done for a diode change in the steering wheel, and then that will then obviously kick in the override switch, which is here. We can see it go to yes. Now what we can do then is, up under calibration switches you can actually then assign a calibration selection on override. So when I press cancel you can see my cal jumps to cal 09, and I use this for the anti-lag, for rolling anti-lag. So I actually have under cal 9 on the cal switch select area, I make it jump to cal 1 on the ALS. Now I know that can maybe sound a bit confusing, but under anti-lag calibration select, under you go anti-lag, you've actually got the ability to have 4 calibration options. So I make it jump to this one, which is then for my rolling anti-lag. Now, for example, say you want to adjust your boost control, you can change your manifold pressure duty for each calibration switching. Your base duty, you can change your target boost, your target limit map. You can even change as much as your fuel map. So if I wanted to make it so that I had an anti-theft mode, for example, I could basically set the calibration 2 will jump to base fuel map 2, and under the fuel map, if that's set at 0, when I now go up to that table, you can see the engine stops. And that's done as exactly what I wanted. It's jumped to this calibration, and that table is 0, so the engine won't run. Go back to 0, back to 1, sorry, we'll change that back, and then the engine will jump back into life. Now, also, the one area that's important to mention is the engine trips. These you can basically assign to be yes or no, depending on the calibration position. But these are also the override. These are all like the general on-off switch for the engine trips. So if you want to have it like I have a lean on load lambda, a lean lambda trip, I just have it active yes on every single one. So it's worth bearing that in mind if you are planning to use some of the engine trips and how you can turn them off. Other people, what they do is they can have one of the override switches set to no, and then in the event their lean lambda trip was present and they want to clear it, they could just press the override button, it would go to no, it would clear the state, and the limp would turn off, and then they can carry on with their journey. So it's like a limp clearing way to think about it. Also, for logging, you can turn the logging enable to off in a certain calibration. So say something has happened with the car, you want that log to be stored and not any more logging to carry on, then you can just jump up and change that to cal, so that's off, and then when you go to that one, the logging all of a sudden has stopped. You can see it here, logging active. Put it back in, and it will turn on again once I reach the threshold for the the RPM or the TPS. So hopefully that's been a good understanding on how you can set the calibration switch up. You can also use these calibration switches as shown here for traction control and launch control adjustment as well. So under traction control here, your traction control switch, you can assign that to that, and then under traction control here, you can choose it to be a multi-position switch the same way. And then what that will do is under calibration switches, it will then take control of the default TC selects, and that will follow. If you don't have a traction control switch or launch control switch assigned, then the TC1, the TC switch select position, if I open up a gauge for that, will actually follow the calibration switch. So as I change that, you can see it changes 2 and 3. So it saves you having to have those switches if you need to. Hopefully this has been useful.